This problem reads, what is the mass of one atom of silicon? First of all, in AMUs, second of all, in grams, and then thirdly, in pounds. So first of all, we go to the periodic table and look at silicon on the periodic table. Now, that mass, 28.09, we're talking about the mass of one atom, that's in AMU. So one atom of silicon weighs 28.09 AMU. But I want to know what is the mass of one atom in grams. So we're going to move across our roadmap. So we're going to start out with one atom of silicon and realize to get from atoms to mass or grams, we must move through the mole. Our first conversion factor is we know that 1 mole is equal to 6.022 times 10 to the 23rd of anything. In this situation, we're talking about atoms. That's Avogadro's number, equals 1 mole of silicon. So I've moved from atoms to moles. My atoms cancel out, and now I go on to mass by way of molar mass. Now, molar mass is numerically the same as my mass of one atom in AMU. It is 28.09 grams per every 1 mole. I put mass of our moles for one reason only, so my moles cancel out. Mathematically, I multiply across the top, divide across the bottom, and I have my answer. I gave you an ambiguous number, 1 atom, so again, remember by default we work with 3 sig figs. So our answer here is 4.67 times 10 to the negative 23rd grams of silicon. That's the mass of 1 atom of silicon. Now part C, I want to know pounds. Well, then we have to use a conversion factor. Going back to our first unit, we know that there are 453.6 grams per every 1 pound. So in this situation, I start out with my drawn out version before I round it up for part B. And I know from grams, to get from grams, I plug in my conversion factor. There are 453.6 grams per every 1 pound. I put pounds over grams, not grams over pounds, because I want my grams to cancel out, and I divide, and I end up in pounds. Another example says, what is the mass of 1,500 sulfur atoms in grams? Again, I'm going across my roadmap from atoms to grams. And I realize to get from atoms to grams, I must pass through the mole. Again, we have 2 conversion factors here. So I start out with 1,500 atoms of sulfur. To get from atoms to moles, I use Avogadro's number because I know 1 mole equals 6.022 times 10 to the 23rd of anything. In this situation, I'm talking about atoms. So 6.022 times 10 to the 23rd atoms is equal to 1 mole of sulfur atoms. And I put moles over atoms, one reason only, because I want my atoms to cancel out. And then I want to go to grams, so I know that I need to get from moles to mass by way of molar mass, and I get molar mass from the periodic table. So I look up sulfur on the periodic table, and it's a molar mass of 32.07 grams. I put grams for moles, again for one reason, so my moles cancel out, and I end up in grams. I multiply across the top, 1,500 times 32.07 divided by 6.022 times 10 to the 23rd. I have my original value has some ambiguity there, so at least 2 sig figs, no more than 4, and I'll just leave it at 3 at 7.99 times 10 to the negative 20 grams of sulfur. A third example here, we get a little more involved. Now a student measures a solid aluminum block. Again, we are assuming it is a rectangle because I give you the length, the width, and the height. So we know the volume is length times width times height. It gives me centimeters cubed. Now, if the specific gravity of aluminum is 2.70, how many aluminum atoms does it contain? I realize if I have volume, well, to get from volume to mass, I have one conversion factor that will do that, and that is density. We also know specific gravity is numerically the same as density. I just have to put units on. So in this situation, I will put grams per centimeters cubed. So I first of all multiply my 4.84 times my 3.68 times my 2.14, and I get 38.115968 centimeters cubed. Again, I'm not worried about sig figs at this point in time. But then I plug in my specific gravity, 2.70 grams per centimeters cubed. I put grams over centimeters cubed for one reason only. My centimeters cubed cancel out and end up in grams. Now I'm in mass, and now I can get to my roadmap. So I know I can go from grams to moles by way of molar mass. And I get molar mass from the periodic table. So I look up aluminum on the periodic table, and I see that it has a molar mass of 26.98 grams per every 1 mole of aluminum. That you can see from grams to moles. But I want to get the atoms. So then I go from one atom I know is equal to 6.022 times 10 to the 23rd of anything. In this situation, it's atoms. So my moles cancel out, I convert to atoms. So I will take 102.913 times 6.022 times 10 to the 23rd divided by 26.98, and that will be my answer. Now sig figs, I go back to my original values. Each of my original values, my measurements, have 3 sig figs. Therefore, my answer has 3 sig figs.